How to measure the circumference of the whole Earth? This seems like a daunting task because Earth is so huge. There is no way we will be able to measure it with our hand and a tape. It's so big. So how did the people earlier? Today we have satellites. Today we have machines to have. Today we can just simply do calculations like none other. We have relationships, examples, so many things. But before that, how do we know what is the circumference of the Earth? But before we can know that, we have to know what is circumference. Circumference is basically length. Imagine a straight line, like for example, a rope of 5 meters. That 5 meters would be the circumference of that rope. But since rope is only one-sided, we will call it length or side. And its circumference, if it is ours, is same as the length. Circumference is the length of the shape. So if we have a rectangle has four sides. So if one side is equal to circumference of the rope, the rectangle has four sides and rectangle circumference would be sum of all the sides. Okay, and that we call it as perimeter in the example of rectangle or a square. But if you have a circle, if you cut it, it becomes floating rope. So the length of the rope is the perimeter of the circle, is the circumference of the circle, is the side of the circle when it is cut and presented as a straight line. So now you know that. Now, how do you go about in measuring the Earth's circumference? And many people have done it very beautifully. And one of the ways is to have a relationship of some kind. If we can have a relationship of some kind, we can know how what is the circumference. For example, one way is to do is take a very giant rope, pin it where you're standing, and circle it around the earth till it comes back to you. Whatever the length of the circle will be, that will be the circumference of the earth. That's almost an impossible task. The another thing is to have the relationship of the sun, because sun is a constant thing in the sky. So if you can have a relationship of the sun such that it deviates with the length of the earth, it will have an answer. For example, what you can do, you can put a stick in such a way sun is above that stick, and you'll see there is no shadow. Okay, and what you can do, you can put another sticks maybe at 1 kilometer distance. Okay, and you just need to find the time when the sun comes to that stick and that another stick also has no shadow. So what you have done is basically you have done that it takes sun, maybe let's say it happens in 5 minutes. 5 minutes to travel a distance of 1 kilometer. Okay, and you know there are 24 hours in a day, so you can do this multiplication and you have the circumference of the circle. Of course, this is a difficult task because the circumference of the earth is huge, and to have the another point which had the no shadow, which had to be kept very far apart. So you can do it by trial and error or making just a long chain of activities. We can just do it. Doable, and people have done it and get very close to the circumference of the earth. But now we don't have to. We just simply have a machine set in the measurement. But despite this, we still use some kind of measurements to measuring the universe, because we do have satellites to measure their circumference today. But we don't have something to measure the scale of the universe. The universe is so big, so huge, massive. So what we do something similar, like in the circumference of the earth. We in the circumference of the earth example, we measure a small portion with a relationship and then simply multiply to get the earth's circumference. We do to count the number of stars or galaxies in the universe. We just pick random spots and measure the stars or galaxies in that area, and then extrapolate it to the whole of the area visible to us. And that's how you get a number like 2 billion stars in the universe or trillion galaxies in the universe. That's how we know. We have not counted all the things. It's just a guesstimate. It's just an extrapolation. It's small units because as of now, don't have the bigger instruments to measure all of this. But like in the previous example, it's very close to reality. That's it. See you guys.